Okay, now that you have your spreadsheet fully programmed, there are a couple things that you are going to need to do with it. So the first thing is we are going to use these spreadsheets to analyze different situations, similar to the distracted student who was in the parking lot. The biggest thing to remember is that you are only going to change the green cells in the spreadsheet. So you do not need to change the yellow or any of the red. You don't want to touch those, just the green cells. So you will be changing the starting velocity. There's 3 different places where the starting velocity needs to be changed: time of distraction and time of reacting. The ending velocity isn't green, but you don't need to change that. That should always be set to 0 because you are trying to stop the car. If you're trying to stop the car, your ending velocity should be 0. Okay. The deceleration rate and then the starting distance to the walker should always be 33 meters unless otherwise stated. So actually, the only time you don't or you do need to change the starting distance to the walker is at situation 7. All right. So spreadsheets will calculate the total distance the car traveled and whether or not the walker was hit. All you need to do is change all of the green and this should happen smoothly. So we can try this with scenario 1. All right. Open the assignment, did the walker get hit, which I called the texting and driving scenarios. Replace all the green values with the following and do not type anything in the units. Leave the units the same. You only change the number. So for situation 1, there are no distractions. What I need to do is I need to change my velocity to 10 meters per second, my time of distracted to 0 seconds, and my time of reacting to 0.5 seconds. My deceleration rate is -8 meters per second per second. So if you don't know, I got all of this information from this assignment right here. Did the walker get hit scenarios? And I am starting with my first one, the no distractions. So my spreadsheet should be opened and everything should be programmed. I can double check that by just clicking on the outputs, which should give me a coded form. Okay. Just double checking to make sure everything is already coded. All right. Scroll down here, double check, it's all coded, and my fun phrases is also coded. Perfect. So I know my distance to the walker is 33 meters, so I'm going to put that in. And then I am going to put my numbers in here. So 10 meters, my time of distraction was 0, 10 meters per second again. And then it was 0.5. Is that correct? Yes, 0.5. Again, my velocity of the car before braking, still 10. My velocity after braking is 0. My deceleration rate is -8. And boom, everything should be calculated. And I am at 11 meters. So because this number, this red number, is smaller than this green number, that means my walker did not get hit. If the number is greater than, so bigger than this 33 or equal to 33, that means my walker did get hit. So I'm going to go over here and I'm going to put 11 meters for what is the total distance. Okay. And then, no, my walker did not get hit. So that's how I do the first part. Now, scrolling down to the bottom part, where it's data and graphing of computational reasoning, distracted distance, okay, d equals v times t. So distance equals velocity times t is my general equation or my science equation. So I can find these different equations on my slides for today. They are actually all in these different areas of braking, reaction, and distraction. So my next one to find is distraction, which is distance or reaction, not distraction, sorry, is equal to velocity times, oops, that should actually be t. So I'm going to change that. So d equals vt is actually the same as the top. Time of braking, okay, right here. Time of braking is that. So I would type in time of braking, or TB equals final velocity minus initial velocity divided by acceleration, and then braking distance is right here. Ooh, that's a long equation. I'm just gonna copy and paste that. I can actually change. There we go. And then my total distance to stopping is the same as dt. This is the total distance. So dt equals dd, so distracted distance, plus reaction distance, plus stopping or braking distance. All right, so that's my equation. And then I need the code format. So for distracted distance, I'm just going to go back to my spreadsheet, scroll up my distracted distance. Boom, here's my code, equals C3 times C5. So equals C3 times C5. So that's what you do for the code format. And then when I scroll down to this area, it says come up with 6 different times and record them on the table below. Make sure the times are at least 1.5 seconds apart. So I can do 1.5, 3, or I can go up by, let's say I want to do just cleaner numbers. So let's do 2, 4, 6, 8, 10, 12. So then what I do is, now that I have my distracted distance or distracted times, it says plug the times into the spreadsheet and record the new distances. So I would just go back here and I'm only focusing on this. So my distracted time would be 2. And so I will put 20 meters is how far my car traveled. All right. And then when I am all done and I have all of these different values, I will open up Desmos. Okay. I will open up Desmos and I will plug the numbers in here. So this is for time and this is for distance. These are my science equations right down here. Remember, once I have my data points, I'm going to move the lines to find my best fit line. Okay, after I figure out my best fit line, I can get rid of all of these other ones and just focus on the one line I need. When I'm done with that one line, I'm going to export it by clicking the share graph button, export image, and then download it. Once I download it, I can put it onto my spreadsheet and then finish filling in the answers there. All right. So that is how you use your programming sheets to find your answers, and just a quick refresher on how to use Desmos in general.